Hi, it's Paul Anderson, and this is Science and Engineering Practice 6. It's on constructing explanations and designing solutions. And so the goal in science education is to have our students constructing explanations and then designing solutions. And so what's a nice progression for that? In other words, if we think of the analogy of a bullseye, we want our students from day one in elementary school throwing darts at this board, constructing explanations, and then over the years we want them to get better and better and better and better, closer to the bullseye. And so the framework suggests owl pellets as a good way to get started in elementary. So basically, you order these owl pellets. These are from a long-eared owl. Students break it apart. They get the bones out of it. They use a sheet to figure out what rodents are in there, and then they're trying to construct an explanation. So what are they trying to come up with? What do these owls eat? What does their diet consist of? And you want students making guesses really early in their education. Or we could give them plant growth, for example. So students could be growing plants in school. They could make guesses as to what could increase plant growth. So they might come up with the idea of sunlight. So they need a certain amount of light. And so you could increase the amount of light and see how that affects plants. But maybe you don't water them and they die as a result of that. Well, now this is a new explanation, so we have to get better and better and better. You want students making guesses, and you can do that individually or as a class. As we move into middle school, the problems can be harder, but the explanations are very important. So an example, this is one I ask my students all the time. Why does boiling water bubble? Like, where are the bubbles coming from? And a really common guess is that it's hydrogen and oxygen gas, because we know that there's H2O. That'd be scary if you had hydrogen and oxygen gas coming out of boiling water, because they're both, it's hugely explosive. So it's not that. So you want them making guesses and then modifying those guesses to fit with established theories that we have. It's also important that they start designing solutions. And so you can do this in elementary, like bridge building are great competitions that you can do where we can test out different designs. And that can move all the way up through high school in big designs. Like this is a solar car competition. And obviously you can't do that in a classroom, but it's something that your school should be working on. And we could do this, like this is something I do in my class. We do water quality testing where we're looking at the quality of the water in the creek that just goes right outside of our school. But we can also build upon that. How can we make it cleaner? How we can build up, or how can we clean up the water in this creek? And so designing solutions are important. We want students doing it from day one, but the sky is the limit. In high school, we can do incredible projects. We can make the world a better place, and I hope that's helpful.